All right, we are back, you guys. I hope you did well on your test on chapter 9 on trig. I'm going to attempt to now explain to you what we're doing from here on out. We're going to go ahead and do chapter 10. We're going to start that unit. It's on circles and all of the different parts of circles. So chapter 10 is where we're headed. We're going to go into each lesson, and then halfway through you'll have a quiz about halfway through. I believe the quiz will happen. Let me just double check real quick. The quiz will take place after lesson 10.3. So we'll do 3 sections. We'll do 10.1, 10.2, 10.3, and then we'll take a quiz, and we'll finish up the other sections and then take the test for chapter 10 as well. So I'm going to start with chapter 10. Couple things you need to understand is you're going to need to understand all the parts of a circle. Okay? Lines and segments that intersect circles. So we're going to talk about these things. These are segments that are inside of a circle. Okay? Obviously, a circle has a center. The center point is where the circle will start. You have to have a center before you can start with a circle. And then some of the certain things that create the circle is a radius. A radius creates a circle. That is the red line. That's the distance from the center to the edge. Every radii for a circle is the same length. So any distance from the center to anywhere on the edge of the circle is the radius. A chord is a segment that hits the edge of the circle twice. A chord is a segment that hits the edge of the circle twice. So you're going to see that the green line right here is a chord because it touches here and it touches there. A diameter is also a chord, but a diameter is unique because the diameter has to go through the center as well. A diameter is a chord because it touches both sides and it goes through the center. So the diameter is actually twice the amount of the radius. Okay? Now down to this picture. Okay? I want you to notice too on that picture, the bottom one, that the green line corresponds with the chord. Okay? The green line corresponds with the chord because a chord is a secant that just keeps going. A chord is a secant that just keeps going. A secant is something that has to go through the circle, hitting the circle twice. Okay? A tangent is a line, and it's this blue one, that touches the circle's edge once. A tangent is a line that touches the segment or touches the circle in one spot one time. So you can see that the blue line is a tangent because it touches the circle at point B. And you could call it line AB or line BA, or you could call it ray BA, or you could call it ray AB. It wouldn't matter how you called it, but it is a segment or a ray that can touch a circle one time. Because as soon as it hits the circle twice, it becomes a secant. So you just need to know the difference in those two, okay? All right, those are some of the concepts about things of a circle, okay? Remember, a radius is the same distance on anywhere. So if I were to draw this radius from here to here, that would be the same as the red line, okay? Every single radius in every circle is the same length. Every diameter for every circle is twice as long as the radius. So if I had a radius that was 5, the diameter would be 10. If I had a diameter on a circle that was 20, the radius would be 10. Okay? Those are some important key points. All right? We'll talk about some more key points as we go along that have to do with this tangent line as well, and that has to do with the secant line. Okay? All right, so let's go ahead and start discussing some of the things that you're going to be able to be asked. It says, tell whether the line or ray or segment is best described as a radius, chord, or diameter, secant, or tangent. Okay, so they're talking about A to C. A to C, I would just call a radius. A to B. A to B is the tilde distance across. I would call it, now, best describes. I would call it a diameter. Now, it's a diameter, but now, other words that it could be, I would also call it a secant besides a diameter, and I would also call it a chord. So, but this is the best name for it because it just goes and it stops. If it keeps going, we would have called it the secant. If it wasn't going through the center, I would have just called it a chord because it's touching the edges. But that's the best name for it. So there are other names for this one. Is that clear? There are other names, but that one is the best one for it. Okay? D to E. It says ray D to E. So ray D to E. The best one would be tangent. Okay? And line AE. Notice I said line because it has two arrows on it. Notice I said ray on this one. And on those two, I just said segment. Okay, so line AE, line A through E. A is here, E is clear out here, so it's going through. We're going to call it a secant. Okay? Other names that are best for it. Anyway, that's the best names for those ones. Okay? All right, let's jump ahead. It says in example 1, so this example right up here, says what words best describe AG first, and then we'll say CG, CB, AG. Well, AG, what word best describes AG, segment AG? Because I believe that's what they're talking about, segment. Notice it's segment AG. Well, let's take a look at it one more time. AG to me would just be a chord. So AG is a chord. Now CB, let's see what they want us to name that one. Let's take a look at it. CB, segment CB, I would just call a radius. So that's kind of giving you an idea about what we've been doing. In example 1 again, name a tangent and a tangent segment. Okay, a tangent and a tangent segment. So let's look back at it again. A tangent. Well, a tangent, we would want to call it a ray. So I'm going to say ray BE. I'm going to say ray BE with an arrow just on one side. Or I could say BE with the line in both directions. Either one of those would be correct. And then we can also name, they said name and a tangent segment. So just a segment of it. So we're looking back at it, the segment, I would probably just say, all right, BD or BE. You do want to name the point that it is actually touching, okay? So BE or BD. You do want to name the point that says actually touching, just kind of like we did over here, okay? All right, let's move ahead a little bit. All right, coplanar. Coplanar means two things are in the same plane. So two coplanar circles and common tangents. So we're going to talk about in this plane, two circles can have intersecting points, 1 point or 2 points or no points. Coplanar circles that intersect in 1 point are called tangent circles, okay? Coplanar circles that have common centers are called concentric circles. So over here we have concentric circles, okay? We have no intersecting points here. We have one intersecting point here, and here we have two intersecting points, okay? Well, we're going to talk a little bit about these tangents that can actually take place within circles there's multiple circles on a grid, or in other words, coplanar circles. So two circles on the same picture, okay? So a line or segment is tangent to two coplanar circles is called a common tangent. So in other words, if I were to draw a tangent in from here and here, that is a common tangent for this two coplanar circles. There's also a tangent that comes this way too, okay? There cannot be one here because it would be actually going through the circles. So this one has two external tangents. Does that make sense? This one only has one because there's only one tangent that can hit both circles. This one only has one because there's only one tangent that can hit both circles. Like I said, this one has two because there's two tangents that can hit both circles. Okay? This one would have multiple. This one would have none because you can't put a tangent with a circle that's smaller inside of it anyway. Anyway, we'll discuss this a little bit more when I start drawing some of these in. And you'll understand why I meant there's multiple tangents on that one. And the ones that are on the outside are called external. The tangents that are on the inside are called internal. And I'll show you that, okay? All right, it says, tell how many common tangents the circles have and draw them. All right, well, let's start drawing them. I'll draw them in red. It says use blue. It says use blue to indicate the common external tangents. So I'll do blue for the outside ones. So here's a tangent that's external. Tangent that's external. Okay? I'll do all the external ones first. Okay? External again. External again. External again. External again. And it's supposed to be touching. You just got to draw it a little bit better. If I had a true ruler, it would look a little bit better. Those would be the tangents. Now a red to indicate the common internal tangents. So red to do the common internal. So there's that one. Well, you better draw that one a little bit better. And there's that one. So there's two internal on this one. There's only one internal on this one. Better draw it better. And then there is no internal ones on that one, because if I were to draw that one in, it's actually going to go through it, which is a secant, and we don't want a secant, we want tangents. So this one has 4 total, 2 outside, 2 inside. This one has 3 total, 2 outside, 1 inside, and this one only has 2 outside. Okay? Hope that makes sense. All right. Tell how many common tangents the circles have and draw them. State whether the tangents are internal or external, and how many. All right, so we'll do blue for the external ones. So again, we're just practicing what we just did. So there's 1, there's 2. So this one has 2 external. And it has 1, 2, and I didn't draw those very good. Maybe I'll draw them a little better for you. There we go. There we go. So 2 internal. So 4 total. Write that in a different color. Okay. This one, the external. Like it just has that one, and you cannot draw any other tangents. So 1, and it's external. Okay? Just 1 external, and then this one, none. Okay? Well, I hope that makes sense, and I hope that'll help you when you go to do your own. Okay? All right, let's talk about some of these. I told you, once we started talking about tangents and secant, there's going to be some rules that we go along with it. Well, these 2 rules are for tangents. It says, in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius, or from the radius to the edge of the circle at the end point. So, here's what they're talking about. We have a blue line that's tangent. As long as you have a radius that hits it and creates a 90-degree angle, then you have a tangent for sure. So it won't matter where I draw the radius in. If the radius is drawn and it makes a 90, then you are guaranteed that the blue line is a tangent, okay? And we'll see how we can prove this in a little bit. We'll be proving it by using Pythagorean's theorem. I'll show you in a minute. Okay, well this one is pretty cool. If we have two external tangents, now the external ones are on the outside. Notice that was external as well, but then the line was inside. If I have two external tangents meet at the same point, if I have two external tangents meet at the same point, then they create congruent segments. Does that make sense? They have to be congruent, okay? Well then, let me tell you something. If those are congruent, and I draw in my radius, and I draw in my radius, then guess what? You end up with two congruent triangles. You end up with two congruent triangles. But the key is, you guys, the key is that this segment will be congruent to that segment, okay? And we'll prove that by doing some of the problems that we do here in just a minute. So as long as you have two tangents that meet at the same spot, kind of creating this ice cream cone, then the ice cream cone, the two sides that make that cone will be congruent, meaning we can set them equal to each other, okay? All right, let's prove that here. All right, I told you that if we were looking at this one, if we wanted to prove if this was truly a tangent, then you guys, we will end up using Pythagorean's theorem to do this. Because if we have a right angle, then we know we have a tangent. If we have a right angle, then we know we have a tangent. So, watch. Here's the problem. Okay, they gave us this tangent, this radius, and they want us to prove if it's really a tangent. Well, the only way to prove if that line ST is truly a tangent is to make sure that that is a 90. Well, we don't know if it's a 90 unless we do Pythagorean's theorem. So off to the side, I like to just draw my triangle. So watch. We believe this would be the 90. That's 35, that's 12, and 37. 37 is our hypotenuse. We believe. We don't know yet. We will find out. So C, A, B, 35 squared plus 12 squared equals 37 squared. We'll do our math. 35 squared is 1225 plus 144 equals 37 squared, 1369. So 1369 is the number we're looking for. So now we'll add these two up. 1225 plus 144, and we get 1369 equals 1369. What have we just proven? Okay, so that's true. Well, if that's true, then we know this is a 90, really, truly right here. Notice I did not put the box there until after I proved it. Therefore, yes, it is a tangent. Okay, we proved it. And that's some of the problems that you're going to be doing today, okay? All right. In the diagram, point B is a point of tangency. So they're saying this is a tangent point. So therefore, this is a right triangle. It says find the radius of circle R, or find the radius R of circle C, sorry. So we know that is a tangent. So we know that's a 90. So over here we have our right triangle. I just drew it the opposite way. Maybe that's going to mess you up, so I'll draw it correctly. We will just draw like this. But when I draw mine, I like to draw them kind of squared up. So this is 80. This is R, and this is R plus 50, everybody. That is the key, that you understand that that ends up being R plus 50. okay? Now, this is where it kind of gets a little bit, you've got to go back to when we did foiling. So watch. We won't do it right off the bat. We're going to label everything. This is C. This is A. This is B. So we're going to use Pythagorean's theorem to help us do this again. So watch. R squared plus. Notice, if I have letters, I put them in parentheses. And I really should have done that with those numbers last time. R plus 50. I hope everybody understands why that's R plus 50. Because 50 is only from that blue part to there, to the edge of the circle, and then from the radius is the red line. And together, that makes R plus 50. Equals 80 squared. And that's really the way I should have wrote the last problem with all the parentheses around everything. So now watch. We have R squared plus. We're going to do our, oh man, Mr. Lee, you really messed that up. Do not let that happen to you. What did I just do wrong? And I've told you this in class, I've done this before. If you mess up where you put the C value, you will definitely miss the problem, okay? The hypotenuse always has to be away from the two A and B sides. And I just put that side on the wrong side of the equation. So I'm gonna reset it up. R squared plus 80 squared, that's where I messed up, equals R plus 50 squared. And I'm gonna have to move it over here a little bit just to have enough room. So this is R squared plus 80 is gonna be 6,400 equals, now we're gonna have to do some foiling. You need to understand, you cannot just take that power in. We really have R plus 50 times R plus 50. There's two of those. Remember, that's what I meant by you're gonna need to be able to foil. So make sure that you do that correctly, okay? So now we're gonna foil this, R times R, so we're gonna leave this alone. That's gonna be R squared. So that one times that one. I'll do, you know what, I'm gonna use my colors to help you. So R, now R times 50 is gonna be a plus 50R. Then 50 times R is gonna be a plus 50R. And then 50 times 50 is gonna be a plus 2,500. So now we have what we have. Now we'll just combine our middle terms. R squared plus 6,400 equals R squared plus 100, R plus 2,500. Okay, now we have R's and R squareds on both sides. Anytime you have the same thing away from the other same thing on the other side of the equal sign, they're gonna just end up canceling out. Because watch, minus R squared, cancel, 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 cancel. So they just went away. So I'm gonna bring my whole problem over here now. 6,400 equals 100R plus 2,500. Let's just do some opposite rules. We will subtract the 2,500. Cancel, cancel. And we get 6,400 minus 2,500. We're gonna get 3,900 equals 100R. Divide by 100. And R will be 39. So the radius on this problem, you guys, is 39. Okay? And we could prove that. We could actually test it and prove it. We would then put 39 right here. We would put 39 right there. 50 plus 39 is 89. And so this total distance is 89. And if you did 39 squared plus 80 squared, it will equal 89 squared. And that would be the proof to it, okay? So you will be doing some problems like this, and they will require you to, get off the computer, get a piece of paper, write some stuff out. You will not just be able to do these ones in your head, okay? So make sure that you get a piece of paper out and you actually, write it out. They will look like this, is that clear? When the problem looks like this to start. All right, we have two more to go. All right, well, What does this one look like? This one looks just like our cone picture right here. And what did we say was unique about this one? That the two tangents would be equal when they meet outside at the same point. So let's take a look. We understand now that this RS is a tangent of this circle at point S, and RT is a tangent of circle C at point T, which creates congruent, congruent. Therefore, 3x plus 4 equals 28, and we'll solve for it. Minus 4, 3x equals 24 by 3, x equals 8. So let's find the value of x, and we found it. That one's pretty slick because of what we were able to do. Okay? And our last one, let's take a look at this. All right, well, let's prove if it's tangent. So now this kind of just putting it all together. Let's prove if it's tangent. Do it one more time for you on each one of these problems. All right, well, I would label everything. Now, here's the key on this one. Notice that line does not go all the way. It's only showing you that this little piece from right here to here is 2. I know that because if I'm proving if that's a 90, if I'm going to prove if that's a 90, this side better be longer than either of the sides. Remember Pythagorean's theorem. So I'm calling this then 3. So this total distance is 5. And I hope everybody understands why I know that's 3. That's because that's a radius of 3, so that's a radius of 3. So we have 3 squared plus 4 squared equals 5 squared. That's going to be 9 plus 16 equals 25. And we have 25 equals 25. So yes, it's a tangent. DE is a tangent. Okay? All right, they want us to be able to find the radius for this problem. This one's just like our last one that we did a second ago. What I'm going to do is just help you kind of set it up. I'm not going to finish it just because of the sake of time. Okay? Maybe I will. We'll see. All right, we need to prove if this is, well, we already know it's a tangent. It says ST is the tangent of circle Q. So we already know it's a tangent, so we already know that's a 90. Okay, well, this whole side right here would be called R plus 18. This side, it would be R. This side's 24. This would be A, B, and C. So we're going to set it up as R squared plus 24 squared equals R plus 18 squared. Then it's back to the same process that we did a minute ago. So R squared plus 24 squared is 576 equals, now we're going to write this twice, you guys. Make sure you do that. R plus 18, and then we'll FOIL it. So we get R squared, we get plus 18R, plus 18R, and then 18 times 18 is 324. Sorry, I'm running out of room, but you get the idea. R squared plus 576. The R's are going to cancel out, the R squareds. These will cancel out. We are left with 576 equals 18R plus 18R, which is, we just do that together, 36R, because we combine those, plus 329. No, 324, sorry. Then we have opposite roles, minus 324, minus 324, cancel, cancel. And we get, I'm going to flip this around. I like that. My variable goes on the left. So 36R equals 576 minus 324, 352, or 252, sorry. Divide by 36. Divide 36, and we get 7. Again, That's about how long that problem's always gonna take you, okay? It's the same work we did just a second ago, okay? And our last problem is point M and point N are points of tangency. So we know that's a tangent, that's a tangent. Well, if those are tangents, then we have a 90 and we have a 90. And then we have congruent and congruent. Well, then we would set up x squared equals 9. If you remember, how do you get rid of a square? You square root it. So that's what it looks like. I'm going to rewrite it. So you see what we're doing. Cancel, cancel, cancel. X will equal. Now remember, it's plus or minus. Why is it plus or minus? Because there are two answers for x. One could be a positive 3, and one would be a negative 3. Now, here's the glitch. We are dealing with a distance, therefore we throw away basically the negative. And so our answer is just 3. But in reality, there are two answers to that problem. One is a positive 3 and one is a negative 3, but we don't have negative distances, so we throw that negative away. Okay? I hope that really helps you with those examples I did. Good luck on your assignment. We'll see you next time.